All right, let's take a look at the opposite process, writing an equation from a sentence. That skeleton equation, that unbalanced equation. Again, it's a good idea to kind of break this down into parts. The first thing I would do is find all the substances that are in the sentence. I've got zinc. I've got lead 2 nitrate. I've got zinc nitrate, and I've got lead. And all I'm going to do is make a little list of those. Zinc, lead 2 nitrate, zinc nitrate, and lead. And just making a list of what I've got in my sentence. Next thing I want to do is figure out which of these are my reactants, which of these are my products. And for that, I'm going to base it on this phrase right here. Reacts to form. What that's telling me is these things that came before it are my reactants. The form tells me these things that come after it are my products. That's going to become important when it's time to write the final equation for this. Now that I've done that, I can focus on the next thing I have to do. The next thing I have to do is turn those words into formulas. So I'm going to look at what I'm dealing with. It's zinc. It's a one-word name. One-word names are usually elements. Now, if you have water, that's H2O. If you have ammonia, that's NH3. If you have methane, that's CH4. Those are the rare exceptions. Almost every single thing that has a one-word name is an element, and that's no exception here. Zinc is an element. Its symbol is Zn. Now remember, we have 7 diatomic elements: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. If it had been one of those, we'd have to put that subscript 2 on it. And again, it's only with those. Now we move on to the next one. Lead 2 nitrate. That's ionic. And there's a couple of ways I know that's ionic. First of all, it's got a Roman numeral in the name. Only ionic compounds can have Roman numerals. The second way that I know it's ionic is there's no prefixes there. No monos, dis, tris, tetras, etc. This is ionic. And when it's ionic, I've got to do the crisscross method. So lead is Pb. When you try to look lead up on the periodic table, you don't find a charge. That's because it's one of those less predictable metals. That's what the Roman numeral is there to tell you. That Roman numeral is there to tell you that lead is a +2 ion. Nitrate, ATE, that means it's a polyatomic ion. If it ends in ATE or ITE, you're looking at a polyatomic ion. You look at your table of polyatomic ions, it tells you what nitrate is. It's NO3, and it tells you it has a -1 charge. Now we got to swap the numbers, so the 2 is going to come over here. The 1 is going to come over here. We check to make sure we can't reduce those, and a 1 and a 2 can't be reduced any. We write our formula. We don't include the 1. Don't write 1s in formulas, so it's just Pb. And then before you put that 2 on the nitrate, you have to put it in parentheses. That 3 is part of the formula for nitrate. You are not allowed to change that. So we put it in parentheses to protect the 3. Pb NO32. We move on to the next one. Again, it's ionic. This time I only have one way to know it's ionic, and that's the fact there's no prefixes in it. We could look zinc up on the periodic table, see it's a metal, but it's just far easier to notice. No monos, no di, no tri, no tetra, no prefix means ionic. Again, ATE means we're dealing with a polyatomic ionic. So we're going to have a polyatomic ion in there. Zinc is Zn. That is a predictable metal. Zinc is always a +2. Why there's no Roman numeral there this time. We can look it up. Nitrate is still NO3. And it's still a -1. Again, we got to swap the numbers with the 2 coming over here and the 1 going over here. And just like before, write that formula. Don't write down the number 1, and make sure you put the NO3 in parentheses. ZnNO3 2. And then finally, lead. One word name means it's probably an element. Lead is Pb. It is not one of the diatomic elements, so we don't have to put that 2 on it. Again, just like in the previous video when you were writing the sentences, there's a lot of repetition as you move down there. Once you figure out these first 2, then the next 2 are just a recombination of what you saw up there. The zinc and the lead basically traded places as you went down. You still have lead up here, lead down here, zinc up here, zinc down here, nitrate up here, nitrate down there. There's a lot of repetition. So if you do these as a list and treat it as a separate assignment, really, I think it makes it a lot easier. Now, once we've done all this, we're ready to write the equation out. And at that point, I really don't care what's up here anymore. In fact, I haven't come back to this since I identified my reactants and products. That's really all I need the sentence for. At this point, I write my equation, and it's a reactants first, arrow, then products. And it really doesn't matter what order we write our reactants and products in. So our reactants were zinc and this, the lead 2 nitrate, which we now know is PbNO3 2. Arrow to separate the reactants and products. These are my products. ZnNO3 2 and Pb. Okay, once you've gone through the process here of figuring out what the reactants and the products are, you're done with the sentence. From that point, just use your formula writing rules, get those formulas figured out, and then put them where they belong. Reactants first, then an arrow, then products. Let's do the same thing with number 2. Go through and find all the stuff. I see aluminum bromide, I see chlorine, I see aluminum chloride, and I see bromine. Those are my 4 substances. And again, I'm just going to make a list. Aluminum, bromide, chlorine, aluminum chloride, and bromine. That's my stuff. Now I've got to use the sentence to figure out what that stuff is, if it's a reactant or if it's a product. And again, I'm looking for context clues. I see reactive form. That's telling me that these things are my reactants. The stuff that follows is product. So I know that this is a reactant. I know that this is a reactant. I know that this is a product. I know that this is a product. Once I've done that, I don't have to look back at this again. At this point now, I'm just going to figure out the formulas, and then when I write my equation, I'll put my reactants first, and I'll put my products second. Aluminum bromide, ionic. Again, how do I know it's ionic? Aluminum's a metal. It's got to be ionic. The other way I know is that there's no prefixes in this. No monos, no dis, none of that. So I know this has to be ionic. Aluminum is my positive part. Bromide, IDE, means the element bromine, is my negative part. There's only 2 polyatomic ions that end in IDE, hydroxide and cyanide, that are on our list. So if it's not one of those, it's got to be a nonmetal. Aluminum's in 3A, it's a +3. Bromine's in 7A, it's a -1. The 3 is going to come over here. The 1's going to come over here. Make sure they can't be reduced, and they can't. Don't write down the number 1. AlBr3 is the formula. Chlorine, one-word name. One-word name means element. So we look up chlorine symbol on the periodic table. That is Cl. Now that is one of the 7 diatomic elements. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. It's one of the 7 diatomics, so we have to put that 2 on it. Aluminum chloride. Ionic compound again. No prefixes. Aluminum's a metal. Al is a +3. Cl is a -1. Again, the 3 is going to come over here. The 1's going to come down there. Those can't be reduced. Don't write down the number 1. And finally, bromine. One-word name. It's an element. It is one of the diatomics. So we have to put a 2 on it. Now we do our equation writing, starting with our reactants. And it doesn't matter what order we put them in. I'm just going to go down my list. AlBr3 plus Cl2. Then an arrow to separate it from the products. My 2 products are AlCl3 and Br2. I'm asked a lot of times, why is it a 2 over here and a 3 over here? And the answer is you're getting those subscripts in different ways. Over here, it's an element, and it is one of the diatomic elements, so it has to have a 2. Over here, the chlorine's in a compound, an ionic compound. So we have to do the crisscross method to get that subscript. So everything's independent. It's the bottom line. That's what it pretty much comes down to. We'll do this last one, number 3. And again, work it out just the same way. Find my stuff. Calcium phosphate, sodium chloride, sodium phosphate, calcium chloride. Write them down. Calcium phosphate, sodium chloride, sodium phosphate, and calcium chloride. That's my stuff. Now I got to figure out what the reactants and products are. And I told you this in class, and I'll tell you it again now. Don't assume that just because it's the first thing you read, it's a reactant. Check that out. It says form when. These form, making them products. When this and calcium chloride react. These are my reactants. This sentence has been written backwards. It's not hard to do. So again, don't just assume that just because you see it first, it's going to be your reactant. It doesn't always work that way. And again, once I'm done with that, once I've figured out what my reactants and products are, I've got my list done, I'm done with the sentence. I'm not going to look back at it again. Now I'm just going to go through and write some formulas. Calcium phosphate, ionic. I know it's ionic because calcium's a metal and there's no prefixes in here, no monos, dies, tris, etc. Ends in ATE, so I know this is a polyatomic ion. It is polyatomic ionic. My positive part is calcium, Ca. My negative part is the polyatomic ion. And again, we look at that table of polyatomic ions. Phosphate is PO4. Calcium is in group 2A, so it's a +2. Our table tells us phosphate is a -3. 2 is going to come over here. 3 is going to go over here. Those can't be reduced. Put the polyatomic ion in parentheses when you put a subscript on it. If you're not putting a subscript on it, there's no parentheses. Sodium chloride, ionic. It's a metal. Sodium, no prefixes. Basically, again, if one thing's ionic, they're just going to continue being ionic from that point on. If one thing is covalent, they're going to end up being covalent from that point on, just like it was when you were writing the sentences. Sodium is Na. It's a +1 because it's in 1A. Chloride is chlorine. IDE means it's a non-metal. It's in group 7A, so it's a -1. 1's all around. Don't write them down. Again, ionic, it's a metal, no prefixes, ATE, polyatomic ion. Lots of repetition. No surprise, we had Na over here, we have Na over here, we have PO4 up here, we got PO4 over here. Lots of repetition. One's going to come over here. Three's going to come over here. This can't be reduced because we're not going to be writing down that one if we don't put the phosphate in parentheses. And finally, calcium chloride. Calcium was a +2. Chlorine was a -1. 2's coming over here. 1's going over here. Those can't be reduced. So write down the number 1, CaCl2. And again, when I do my equation, I'm just going to write what I see. I'm going to put these reactants first. The reactants always go first. And it doesn't matter what order we write them in. Then I'm going to put my product. And that's it. That's how you do it. It's a lot to think about, but if you break it down into a step-by-step process where step 1, I'm going to figure out what the substances are. Just the stuff, and write them down. Step 2, I'm going to figure out if they're reactants or products. Just go through and do that. Step 3, I'm going to write all the formulas down. I'm not going to think about anything else but writing formulas. And then step 4, I'm going to write my equation, just putting my reactants first, then my products. I think that makes it a lot easier. It takes longer to do, but you're less likely to make mistakes.